Hey everyone, welcome back to my YouTube channel. I was reviewing some code the other day, and typically Tuesday, and I realized something pretty wild. Most developers think security is about fancy crypto and obscure vulnerabilities. But honestly, some of the most critical vulnerabilities are not in the code at all. They are break into the design. And that's exactly what we are talking about today. We are going to dive into insecure design, and I'm not gonna throw definition at you. We are going to look at real vulnerable code. We are going to attack it, and most importantly, we are going to see exactly how to fix it. So stick around me. Alright, so before we jump into the code, let's talk about what insecure design. Insecure design is not a bug. Yeah, it's not a bug. A bug. It A bug is when you write a code wrong. You forget to validate input. You forget to hash a password. That a bug. You can patch it with a hotfix on Friday night. Insecure design is different. It when the architecture itself has no security control to begin with. The system was designed without security as a requirement from day one. Think about it like this: if you build a house and forget to include lock on the front door, is that a bug? No, that is the design flaw. You have to rebuild whole entire way to add security. And that's the problem with insecure design. You cannot patch your way out of it. You have to redesign. So I give you some real example. Hmm. First is a noratelimit on logging item. Design never thought attacker would brute force. Designer never thought attacker would brute force. Session token that never expire. Nobody design an expire mechanism. No server-side validation of user role. The system assumes the client would not lie. And last not the least, password stored in plain text. The architecture never include hashing from the start. These are not bugs, these are missing control. The OWASP top 10 category is under A06 for 2025, and the reason it matter is because it usually enable a lot of other attack. It's not glamorous, but it is the foundation for some devastating exploit. Okay, so how do you spot this stuff when you review code? The key is you are not looking for a bug. You are looking for missing guard. When you when I do a code review, ask myself a few questions. The first question: what's stopping an attacker for doing X? Let's say it is password reset feature. I ask what stops me from resetting someone else's password, and then I look at the code to see if there are actually a mechanism that prevented it. If the answer is well, the front end only show the reset button, no login user. That is not mechanism. That is a security threat, and that insecure design. Second question: what happen if the user submit the request 1,000 times? What happen? Is there a real limit? Yes. Is there a logout? Is there a captcha? Or does the system just accept it? If you are looking at password reset endpoint and they are zero limiting, that's not a bug, that's a missing architecture. Third, what attack surface and what control got it. This is a big when you look at the feature, map out what attacker could do, then look at the code and see is there a security control that stop this. For example, file upload feature. Is there a file type at check? A file size limit virus is virus scanning, this kind of API endpoint. Is there a authorization or input validation? And for the admin dashboard, can a regular user access it? Is there a role check on every endpoint or just a UI? Most insecure design happen because developer think the UI is the security control. The only admin sees the delete button, but delete endpoint does not check role. That is insecure design. Fourth question: Is this control enforced side? Is this control enforced server side? This is the critical. If the entire security control live on client's JavaScript validation, if the entire security control live on client JavaScript validation and hiding button, client side role checking, that not a security control, that a UX feature, and do not use it. Use your UI. They send raw HTTP requests. So if you the only thing stop them is a disable button or hidden form field, you have got a insecure design vulnerability. So let me show you an actual example. I'm using a lab I built to demonstrate this. The vulnerability is in fictional e-commerce site called Shopcut. They have forget password feature. So here is the vulnerable flow. User click a forget password. System generate 4-digit code and email it, and your reset code is 123. User enter the code and they reset their password. Sound reasonable, right? But let's look at the code. Generate the reset token. So already there a problem. First, they are using random function that not cryptographical secure. It is predictable. Attacker have built tool to predict Python random number generate. And second, there is no expire. The token is stored in the database with 0 timestamp. So theoretically that code is valid forever, for a day, for a month. And then look at this endpoint. There is no rel limiting. Attacker can send 1000 requests per second and the server just accept them all, and there is also no expired check either. So what the attacker can request a password reset for victim email, use a simple brute force script to try token 1000, 1001, 1002 up to 9099. Because there is no rel limiting, this taken like 5 seconds. So they find the token, they reset the victim password, and they own the account. There is no password knowledge required. And here is the kick: the token is never deleted after use. So even after the victim reset their password, the attacker still has a valid token and can use it again. And so this is not a bug. This is a missing design control. No cryptography, no expire, no rel limit, no single use enforcement. Every single one of this would require architectural decision from day one. Alright, let me show you in the action. I built a little bit an interactive lab that simulates this exact vulnerability. This is the Shopcut password reset lab. It got two sides: the vulnerable implementation and the secure one. We can actually attack it. So here you go. I'm going to request the password reset for this victim email, and you look, the system generate token. Look at the server log. This is the log. It's just uh, mm, okay. There is no expire, no delimiting. It's just a sitting here. Now I'm going to brute force this token. And you look, in like 5 seconds the attacker find the token, and attacker now has access to this reset account. And see the log, the ultimate attempt, no throttle, no logout, just request after request and accept it. This is what insecure design look like in practice. The vulnerability is not in the code logic. The code was fine. The problem is what missing. Now watch this. Same attacker, but this time against the hardened version. Notice what happened. After the third request, the system says rel limit. Cut this one. Notice what happened. After the third request, the system says rel limit is exceed. The design now include a mechanism that stops this attack before it happened. Now I try to brute force. After a 5 attempt, the system blocked me, and look at the token is 256 bit of cryptography randomness. So even if I had an infinity request, I need to the power of 120 ADR of gadgets. That is the difference. The secure version was designed with control from the start. So how do we actually fix insecure design? Let's look at the code. First is a cryptographical secure token. That is the one line. Secret module instead of random. Now we have the 2056 entropy instead of 4 digit. Brute force become impossible. Second is token expire. We store an expire timestamp. Now token is valid. Valid for 15 minutes. And even if attacker intercepts an email, the window is very tiny. Third is rel limiting. We limit reset requests to 5 per hour per email. Attacker cannot spam reset request to an invalid account. 4 is rel limiting to token verification. We limiting verification attempt to 5 per 10 minutes per IP. So even with weak token and brute force is now infeasible. Last, fifth but not the least, after token is used, once we delete after token we use one, we delete it, and replay token are now invalid. Notice something, all 5 of these fix are architectural decision. They don't patch, they're not hot fix, they require think about security from the beginning of the design. That's why this vulnerability category exists. We cannot write a patch for we forget to design security in. Alright, so alright, if you doing a code review and you are looking at new feature, ask yourself what's stopping an attacker, and then look at the code and see if there a actual answer. If you are building something, think about the control before you write the first line. Do not bold them on a letter. So if you found this useful, hit the subscribe button, and if you want to try the lab yourself, I will link it in the description or comment section. You can actually attack vulnerable version. So see how it fall and play with the secure one. So thank you for watching, and I'll see you in the next video.